right, this has to be very quick today because we are short on time. This is, that's right. So it's 6:05. I don't even take the time to do that. What we're going to do is we're going to talk about, actually, I've got one. Oh, I know. I actually, boom, there it is. I pre-copied it. Okay, so there it is. Look at this thing right here. It's a parallelogram, but it's not just any old parallelogram. What do you think is true about this parallelogram that may not have been true about other parallelograms? Yeah, the sides are equal to each other. Well, it's not regular. In order to be regular, all the angles would have to equal each other as well. Okay? There is a regular parallelogram, and maybe we'll talk about that in a minute or so. But watch, these four sides are equal. We call this a rhombus. Rhombus. B-U-S. R-H-O-M-B-U-S. It's a rhombus. It's a parallelogram that has all four sides equal to each other. Okay? If it's a parallelogram, all the other stuff is true too, right? Opposite sides are equal. We already know that. The opposite angles are equal. Blah, 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 all that good stuff about parallelograms. But let me just show you the special stuff that's true about a rhombus that's not necessarily true about other parallelograms. Let's do the diagonals here. You got a diagonal right there, and you got a diagonal right there. Now, we just learned yesterday that the diagonals of a rectangle are equal to each other. Well, this is not a rectangle, so the diagonals are not equal to each other. We do know they bisect each other because it's a parallelogram, but there is something special about this that's true about a rhombus. Look what kind of angle is formed here of the intersection of those two diagonals.
Right.
That's right. Right angle. That's only true about a rhombus, okay? Only when you have a parallelogram that's a rhombus are the diagonals perpendicular, okay? So the diagonals are perpendicular. That's a special thing about a rhombus. Everybody got that? There's also something else special about a rhombus. Look at the angle right here. Look at this angle and look at this angle. They are bisected, that's right. So those diagonals do a couple things here. The diagonals are pretty special on a rhombus. They're perpendicular, and they also bisect the opposite angles. Now, what's true about the opposite angles of any parallelogram at all? They're equal. So if this big angle is equal to this whole big angle right here, and this one's bisected, so I've got this angle is equal to this. Instead of saying this and this, let's do this. 1, 2, 3, and 4. Is that all right? So 1 and 2 are equal, but guess what? 3 and 4 are equal to 1 and 2. Does that make sense? Because the whole big angle is equal to the whole big angle, right? They're both being bisected, so if I take two equal angles and bisect them both, what's left over? All four equal angles. Make sense? Same thing up here. So this angle and this angle is equal to these two down here. All right, so that's kind of a special thing about a rhombus. What if I had two rhombus? What would I call it? Rhombi. That's right. Call it rhombi. That would be I'll put a PL right there for plural. Okay? So that's singular and that's plural. So rhombi. And that's the title of this lesson, by the way. Rhombi and what else? Squares. Well, since you mentioned a square, let's talk about a square. There's a square right there. Now, what do we know about squares? Well, square is a whole bunch of things. First of all, a square, it's a quadrilateral, but it's also a parallelogram that has what? All equal sides and, what am I drawing though? All right angles. Now, if I just had that right there, what would I call this thing? A rectangle. I would call it a rectangle. So square, technically, is also a rectangle, isn't it? So that's right. Rectangle is not necessarily a square, but every square is always a rectangle. Okay? What about this? A square also has all four equal sides. What did we just learn just a minute ago about a quadrilateral with four equal sides? It's a what? It's a rhombus. So guess what a square is? A square is also a rhombus. So a square is everything, isn't it? Well, not everything, but it's a quadrilateral, it's a parallelogram, it's a rectangle, and it's a rhombus. Right? So a square is a whole bunch of stuff. So guess what's true? Let's do the diagonals. Now this is pretty cool. Watch this. Since it's a parallelogram, you know the diagonals bisect each other, right? Since you know it's a rectangle, a square is a rectangle, the diagonals are equal to each other. Got it? Since a square is a rhombus, guess what happens? They're perpendicular, and all the angles are equal to each other, right? So look, this angle is equal to this, is equal to this, is this, and this, and this, and this, and this. Exactly right. And you can tell exactly how many degrees they are without even putting a number in there. Since I'm bisecting a 90-degree angle, how many degrees is every one of those single angles? 45 degrees. Very good. Everybody see that? And we got right triangles in here too, don't we? Got a right triangle right here, and so on. So that pretty much covers. Let me show you one more thing real super quick before you go. Okay, here's a oops, let's do that. Here's that rhombus again. Watch this real quick. Are you watching? Watch this. If this was a rhombus, actually I should say this. If this was a parallelogram, and if this side was equal to this side, that's all I knew. Everybody listening? If that's all I knew, then that thing right there is a rhombus. Okay? That's all I have to know. If that thing's a parallelogram and two of the sides are equal, that automatically makes that thing into a rhombus. Yeah, homework. What's everybody leaving for? I dismiss. The bell doesn't dismiss. 431, 432. That's the page number. And it's 7 to 12. And it's 19 to 30. 19. 7 to 12, 19 to 30. 7 to 12, 19 to 30.